Okay? Are you gonna 3D break your own chess pieces? Like that would give you another point for your badge.
I can afford it.
All right, you got any anti-geek traits? Do what? Avid outdoorsman. Okay, fantastic. We are almost there, waiting for the 8th flip. All right, I'm going to go ahead and get started. If you're coming in, feel free, just come on in, sit down. First couple minutes aren't that important anyway, it's just going to be a little bit about me. So you are in Automation for the Win. Hopefully you are detail-oriented enough to know that that is the title of my slides, and if you don't want to hear this talk, then I won't feel bad if you get up right now and leave. My name is Randy Searing. If you're interested in the slides, I don't know that there's not like a whole bunch of code in it or anything, so I don't know how useful they be to you, but you can find them on my public GitHub page if you want, both in source code form, which would have some of my speaker notes if you looked at the main restructured text file, and then also there's a link to they'll show them in HTML if you're interested. I'm the Chief Executive Developer at Level 12. I take that title because I've turned more businessman than developer over the last few years as we've tried to grow, but my heart is still primarily as an engineer, as a software developer. I love this stuff more than I love all the business stuff. It's just that I don't do it as much as I like to anymore. I've been working with databases and web applications for over 15 years. I've been working directly with customers on custom project development for customers for about 12 years. My customers aren't big players. They generally are not in tune with best software development practices. They are what you might call a typical, you're run-of-the-mill businesses. I'm usually dealing with either C-level execs or at smaller companies, just like founder type situations. My customers are genuinely naive about the software development best practices, and to be honest, they don't really care. They don't want to have to learn that stuff. That's why they've hired us. They've hired us to handle it. The things they do care about is our responsiveness, our ability to get done what they need to get done for their business as soon as possible. They care about product quality. They don't want bugs in production. And they care about costs. They don't want to get charged an arm and a leg for this. There has to be an ROI for them. So in some sense, I'm working in what I would consider one of the hardest areas, consulting, to do quality software development, because there is a significant pressure to get the job done, just get the code done. Why isn't it done yet, right? And so not only do we have to work with our customers to set proper expectations, but we also need to work on our own processes so that we can get this stuff done relatively quickly, hopefully faster than somebody else who's going to be not using automation, so that when I go in and I present the right way to build software, I'm not adding a 0 or 2 to the cost of these projects. My argument there is really that if this works for me in my context, it's likely going to work for you in your context. So my real world is that these things have been developed, the things I'm going to talk about have been developed over approximately the last 8 years since I really started focusing on automated testing and more recently continuous integration. I'm primarily involved in web and database development. If you're doing like GPU programming or some type of embedded software, I'm not coming from the same context, so you may need to interpret this for your own context. I'm also not operating at scale. If you've got millions or billions of requests that you're processing per second or day, I've also not had experience in that. However, these are best practices. The things I'm going to talk about today are things that the software development community as a whole is promoting and is arguing that you see great value from. So I do believe that even if your context differs, the things that I'm going to share with you today are likely to apply either exactly or very closely, just tweaked slightly for your context. So I'm curious, who I'm talking to. So one of the things about this talk is I hope to have it be pretty interactive. And And so I like to kind of get a sense of who I have in the audience. So the first question I have is, what's your role? Are you developers, QA managers? So let's start with developer. If you're doing software development primarily full-time or close to full-time, raise your hand. Okay, most people in the room, which is what I expected. Okay, how about dedicated QA personnel? Okay, that makes up probably the other majority. How about management or leadership in some other way? Okay, curious what type? What type of management? Like, are you like a development lead, or are you CEO, development lead? I have another leader over here.
QA manager.
QA manager, okay. How about anybody else? Did I miss some job types? What are they? DevOps, sure, okay. DevOps, okay. All right, so pretty much this is the typical audience that I talk to, and it's what I was expecting. So it's good, because what I'm going to say I think applies to you, and you don't have a whole bunch of outliers in the audience. Okay, so for the developers who raise their hands, how many are full stack or multi-stack? Meaning you don't just have primarily one language that you deal with, but there is a breadth of languages that you deal with. Technologies. Okay, maybe a little less than that. All right, let's do business size. How many people are in really small businesses? 10 people or less? Not so many. Okay, medium-sized business, so 10 to 100. Okay, 100 to 1,000. Okay, that's more. How about really big? Wow. Okay, so we have a lot of really big people from really big organizations in here. How many of you would say that you have a solid automated testing? You have solid automated testing and processing, i.e., continuous integration, in place? Okay, maybe 5 to 10. That's always very typical of the response that I get. Okay, so I'll talk a little bit about this presentation, what you can expect here. I'm not going to be showing any in-depth config or coding. As I've been to my conferences, as I've been to conferences, have been in your seat, what I've realized is that it's often very difficult for the participant to follow along in the seat and know what's going on, as well as the developer or the person giving the talk. And so instead, what I'm going to focus on is I'm going to focus on encouragement. I'm going to focus on a technical summary of the layers that are involved in QA later in the talk. In continuous integration. And then I'm hopefully going to answer a lot of questions that come up about how do you do this practically. Because what I find is that even though I'm going to tell you kind of the fairy tale way to do it in some sense, or the best way, the most pure way to do this, reality is that it's hard to actually implement this in your own context. And some of you have run into pretty significant barriers. So I really do, if I'm talking about something and you're like, okay, that makes a lot of sense, but how would that apply in this case? Feel free to raise your hand. I'll get to you and we'll talk about it, because I think that type of dialogue adds more to these conversations than just my continuing to flip through slides as fast as I can. I really do want interaction, so please speak up if you have a question or a comment. If you have a question and you stump me, that's fine. We can all laugh at the fact that the speaker doesn't know the answer. I won't take it personally, but I will try to be funny with you later in the talk. I want to talk about something that's really significant. I feel as a developer, maybe you don't feel this, but there is too much technology for me to really keep up with. Technology fatigue is real. I went Slashdot in afternoons, probably like the rest of you, and it's really difficult to feel like I'm keeping up in the field. And I think there are certain times when technology fatigue is worse, or is at its worst. Can anybody guess what one of those times are? Well, I heard it. Conferences, yes. You are going to walk out of here in 2 days, and you're going to have been exposed to so much. It's easy to walk out of these and feel discouraged. And so I wonder, for those who have been to technology conferences before, how many things do you actually follow up on? As you're sitting here, maybe you're taking notes, maybe you're learning stuff. How many things from a conference have you been actually able to take away and do something significant with when you leave? How many people can say I've done that with at least one topic that I learned at a conference? One. Okay. How about 2? How about 3? And from the same conference, mind you. Okay, so we've got some. So we've got some people who are doing a lot with the things that they're learning. What I've realized is that typically I'm lucky to be able to take one thing away from the conference that I'm really going to focus on for maybe a quarter and really try to integrate it. The rest of it is just kind of, I want to be aware of what's going on, but I'm probably not going to be able to do anything significant with it. And maybe for some of you, I hope that this relieves a little bit of pressure. We are finite beings. We are not infinite, and we have a limited amount of time and attention that we can give to things. And so I just want to encourage you that in light of that, priorities are really important. Pick at least one thing at this conference and walk away from the conference saying, if I'm able to integrate this one thing into my development workflow or into my life in a quarter, I will say that this conference was really worth my time. I'd like to argue that this talk is it. I really believe in automation as a cornerstone in building a efficient and productive software development team. And so I am going to tell you why I believe that. This is not me. So the talk is automation for the win, but I am not a fanboy or fangirl, obviously. I am not jumping on a bandwagon here. I have long-term goals as both a software developer and as a business owner of a software development shop. And those long-term goals can only be accomplished through automation. That's going to be my argument. I'm going to support that here in a little bit. But before I tell you more about what my goals are that automation is supporting, I want to switch and ask, what's your goal? And I really mean this. A lot of times in life, we will progress down a path without ever really having considered what is the reason I'm doing this, or how will I know that I'm successful? And so I want to ask you, what are the guiding principles that govern how you build software? And this isn't a rhetorical question. I'd like, 3, 4, 5 people. Can you name the guiding principles? What are you shooting for as you build software? That if you come out of the end, you've done a project, and you can say, we've done this, 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 and this, the project has been successful.
Maintainability, number one thing.
Maintainability. Can you define maintainability?
Yes.
Keep it simple.
Yeah.
Smart person. Yeah.
Or stability in the production environment?
Stability in the production environment. So that means it's not crashing, or that means there's no bugs?
There's less bugs.
There's less bugs. Okay, somebody said something else over here.
I said readability.
Readability? Okay. So if the code is readable, but it doesn't work, is that okay? No, okay. All right.
So all those are really important as far as the non-functional stuff, but first and foremost has to be, it needs to deliver the expected business value.
It needs to deliver business value. Okay. Anybody else? Last one, that's 4. It's 5. Yes, sir. Has to be testable. All right, so here's my software development goal. I want to sustainably respond to change with minimal friction. So that means that when my business users come and ask me for something because it's important to the business, that I can say yes as easily and as quickly as possible with as minimal damage to the code or the developer mentality as possible. And I also want to be able to frequently deliver highly functional software. So as we think about this statement, there's really 4 components to it. One is flexibility, that is, I want to be able to respond to change with minimal friction. There's velocity, that is, I want to frequently deliver highly functional software. There's quality, the software that I'm delivering needs to be highly functional. And cost. Where's cost in this?
As much as you can get.
As much as I can get?
As much money as you can get.
No, that's not it. Sorry. Where's cost in this? Improving efficiency, but where is it in the definition? What?
Respond to change with minimal friction.
Nope. I mean, kind of, maybe. Wait, what? I heard it.
Sustainably.
Yes, to sustainably do it. Okay, how is cost related to sustainability? Well, if I can't keep my costs within a return on investment window for my customer, are they going to keep doing business with me? They are. It also works for the development side. If I burn out my developers because I have to work so fast to keep the cost down, is that sustainable? It's not. So we get sustainability, and we even get, or we get cost, and we even get developer and team health by adding the to sustainability preamble to this. What's the tension in doing all of this? Change. How is change tension?
Change is hard.
Change is hard. Change also introduces something. What does it introduce? Risk, specifically for software, introduces bugs, right? Introduces bugs. So if we want to move quickly, and we also want to deliver highly functional software, and we want to do it at a reasonable cost, those things kind of conflict, right? They're kind of like pressures from different sides. Okay, so I stole this, or I guess this is a kind of a re-implementation of something that's already out there that you're probably familiar with. What is this? Anybody? It's a term, you probably know it. Agile, yeah. This is the heart of Agile, at least the principles from the Agile Manifesto that deal specifically with software and not so much with kind of team structure. I got a question for you. Is Scrum Agile? Yeah, Scrum as its best practice is Agile. Our second question, is Agile Scrum? It is not. So if you have only heard about Agile in the context of a Scrum environment, and or you've been exposed to some other Agile methodology, and or your experience with those Agile methodologies has been bad, I ask you to suspend that experience for the rest of this talk, because what I'm talking about is not any specific methodology, it's not a program. What I'm really talking about is Agile as a set of principles as defined by the Agile Manifesto. If you haven't read that and you're interested in Agile and you've only kind of been exposed to the methodologies, I really encourage you to go to the source and just read what they're talking about. And what you'll realize is they're not talking about Scrum. They're talking about how to build software in a way that has value. What is software? What is the value of software? And I think that's really important. It's a really important distinction, and I encourage you to do a little research on that if you go away from this talk and you're convinced it's worthwhile. Okay, so remember the title of my talk. My talk is Automation for the Win. This is my win. If I can sustainably build software that responds to change with minimal friction and frequently deliver highly functional software, I've won. I've won. Like, this incorporates everything that I'm doing in my business, everything I'm doing as a software developer needs to support this. And if it doesn't, it should get jettisoned. Okay, so who would say that they agree or strongly agree that this is a noble goal for any software development team? Raise your hand. Agree or strongly agree? Okay. If you disagree, I'd honestly like to, if you stay afterwards, I'd really like to talk to you, just get your feedback. Maybe I can make this talk better, but I'm really interested in hearing the reasons for your disagreement. Okay, so my assertion now is that in order for me to deliver on this goal, without heavy use of automated processes, especially testing, this goal or this truly agile workflow, which is how I'm going to describe this, just because the goal was too big to come. I didn't have a label for it. So truly agile workflow is my label for that goal. Without heavy use of automated processes, especially testing, a truly agile workflow is impossible. Note that there's two components in this. I have testing and I have processes, and the rest of the talk is going to kind of be broken up into into those two categories. And the rest of this talk is my attempt to convince you that this assertion is valid. So let's talk about tests. Who is testing? Who is usually testing the code? One? Really? 2, 3? Come on. Yeah. Okay. Maybe a third. Maybe half. Okay. So what do the rest of you do? Do you write code and ship it? No, you test it, right? You think I'm talking about automated testing, but I'm not there yet. How many people, when they write code, do some kind of validation manually, at least, to make sure that code is running correctly? Okay, all the hands should go up, right? Now, I know some of you have shipped stuff to production without testing it, but then your customers are just testing it, right? You're hoping that they'll report bugs if they get it. But most of the time, most developers are trying to test their code or trying to get their code Okay, so the second question is, how many of you are usually writing automated tests for your code? Okay, so now we have maybe a third group. Okay. If you're not usually writing automated tests, what are some of the reasons that you would say you're not there?
We had automation suites, but the cost of maintenance became too high as the number of tests fell.
Okay, so they had automation suites, but basically it became too hard to maintain those.
The code is written in such a way that it's untestable.
The code is written in such a way that it's untestable. Okay? Yes, sir.
We give status reports that encourage product managers to tell us not to.
Okay, you give status reports that encourages product managers to tell them not to do the testing.
Yeah, we say, well, I'm all done with my story, I just need to write tests and I should be done with those by tomorrow, right?
Okay? Yes, I can see why that would work against you.
As an effort to reduce costs, not the time allocated.
Yes, that's what I wanted right there. I want to reduce costs, I want to reduce time, that's why I don't use automated testing. Okay. For those of you who are writing automated tests, who has at least 25% test coverage of their code base? Okay, 50%. 75%. 95%. Anybody still have their hand up? Oh, I got one over here, okay. How big is your code base? You lines of code? Any idea?
Depends on the project.
Do what?
Depends on the project.
Depends on the project?
Yeah.
Okay.
It can range from anywhere from a small project to a fully functional system that is just about anything you can.
Good, that's awesome, we'll hear. Okay. Okay, and for those who have automated tests as a part of their regular workflow, how many people have those automated tests written by the developers who are writing the production code? Okay, and how many are relying on QA people exclusively or almost exclusively to write tests? Okay, about 5. Okay. Here's another assertion for you. If developers are not creating automated tests in parallel with production code, a truly agile workflow is unsustainable. So I'm arguing that if you're going to have an automated test suite, the developers need to be the ones who are writing the bulk of it. Why? Well, because in software development, most developers are going to be testing their code anyway, right? And I want to get to a point, and I'll go this a little bit later, but I want to get to a point where the effort to test is captured as an asset and is no longer an expense. Because otherwise, you have to continually repeat yourself, and that's unsustainable. And it leads to a point where we basically can no longer test the entire code base. So here's some more of my reasons. So quick iterations and frequent changes, it's going to cause bugs. Remember, that was part of my goal. I want to be able to quickly respond to change with minimal friction, and I want to be able to frequently deliver highly functional software. So those things are working against each other. As I'm changing stuff, I'm absolutely going to break things. And if I want high quality software, then I have to test for and find and fix those bugs that I'm breaking as I continually refactor and add new information. So this creates a situation where the code volume and complexity is going to grow over time, and it's going to become increasingly impossible to manually verify all of the functionality of the application or library. At the end of the day, without automation, the effort expended in testing is wasted. That's where we think about asset versus expense. So here's a visual of this. So on the left-hand side, you have release number 1. In release number 1, all the code is new. It's all new. And if you've done testing, you've done manual testing, hopefully most of it is tested, although from my experience, if I don't have automated tests and we've got a long release cycle, I may test some stuff at the very beginning, and as I continue to develop, I've not gone back and checked that when we do the release, right? It's just too hard. Even in a single release, there can be too many changes to continually fully test everything and make sure that it's working. As releases continue to build, as we continue to build on the software, the existing code quickly outpaces the new code. So if you're relying on manual testing, it's going to happen while the release is being developed. There's no way for the development team or even the QA team to keep up with all of the regression tests, all the stuff that never got touched. it's hard enough to get the release out the door if you're doing manual testing, just testing the stuff for that current release, the bug fixes or the features. How much testing, how much regression testing can realistically be done in a situation where you don't have automated tests? Does anybody think that you can generally do regression tests of most of your code base at every release if you don't have automated tests? Any regression testing? Do you ever get past just testing with the code that was released? By what? If so, maybe what? Maybe 1-2% of the existing code base? Maybe you've got like a core set of functionality that you have somebody manually go through every time to make sure, hey, this has to work. But beyond that, there's almost no regression testing. If anything, you're testing the code that just got released. You're doing core pathway functionality. That's it. Does anybody else have tests? Has anybody in a situation where they realistically have time to do regression testing beyond that in a situation where you don't have automated tests?
On one project we did.
On one project you do. Is it a pretty small project?
No, it took like a month.
Okay, so in that case, you're sacrificing frequent releases, right? Because in that case, you are devoting the time, but you cannot quickly respond. Okay? Anybody else doing that actually? Yes, sir?
We usually try to select areas that we believe may have been affected for additional regression.
Okay.
But still, it's a very, very small percentage overall.
Yeah, so at least you're guessing, right? What could possibly have been affected? Let's go test it. That's better than nothing. So,
I would say, I'm sorry, I would say that the times that we've ever done full regression testing is usually after you get burned.
yeah, after you get burned, sure. So you have a big bug, you lose data, security breach, that you're gonna really, but that's gonna wane over time, right? Yeah. So over time, regression testing will cover less and less code, or that testing will just stop being done because it's too hard to keep up with. This is you, if you're doing manual testing. You are in a losing battle. This is not sustainable. Remember, my goal is to sustainably respond to change with minimal friction and frequently deliver highly functional software. You cannot do that. You cannot sustainably do that if you're manually testing. So I really want to encourage you to think in these categories. Everybody said they're doing testing. If you are not writing automated tests, every test that you have ever done has been an expense rather than an asset. It's been an expense. It's wasted. You can never repeat it. And so for the managers or the leadership, if you're looking for an argument to try to convince your team to do this, and they say testing takes too much time, we're going to talk about that here in a little bit, or it's a waste, right? Well, what's all the testing we've been doing? So when you think about this, and you think in terms of a developer's time, as a developer, what do you think you spend more time doing? Actually typing code into the editor, or verifying that the code that you've just done actually works? What?
Verify.
Yeah, I think so. Anybody want to throw out a ratio? Typing in the editor versus verifying functionality. What do you think the ratio is for the average developer? 20/80? 8/20? It's at least 50-50, right? Even for the people who just like code like you're writing writing a paper or something. But I'm at least for me and the people that I've kind of overseen as we're doing pair testing or helping with something, the actual typing in the editor is pretty slow compared to thinking about the problem, trying to think through edge cases, and then going and verifying that the code that I've just written actually covers that stuff. All of that time spent verifying is wasted if you're not doing automated testing. It's wasted. You never get it back. And you've got really expensive developers spending their really important time doing things that you could spend $50 a month to have a peer review every time you check your code. $50 a month to get you a good CI platform, software as a service CI platform. And all of that time that you're investing, I should say all of it, a large majority of that time that you're putting into verifying now becomes an asset rather than an expense. Now it becomes a locomotive pushing you along that path of delivering highly functional software frequently and responding to change with minimal friction in a way that's sustainable. Here's my second argument. So my first argument was manual testing is unsustainable. It can't happen. If you agree with and want want to build software, as I talked about it at the very beginning of my goal, you simply are not going to be able to do that if you don't have automated tests. Okay, here's my second assertion, because this is a very common excuse that I hear when I ask why don't you test, is because we don't have time or it costs too much. I believe automated testing saves time. And I'm not joking, it really saves time, both in the short term and in the long term. So let me convince you on the short term. This is you, and this is your two-field contact form, and maybe you send an email or log this to a database, and I fully agree with you, fully, that if you're starting from scratch, you have no automated tests built, you can do this faster. You can do this faster, manually testing it than you can do if you build the tests, because it's going to take you a while to build up that toolbox of tests and kind of learn how to do it. Now for me, where I got the toolbox, I know my tools, I've done this before, it would actually, I would argue, it would not be faster, it would be the same amount of time. A form like this, I would actually completely code in tests, and I wouldn't actually even bring up my browser until the very beginning, or until the very end, just to make sure I didn't miss something in my test. But I can do this all in my editor, and with my test suite, I don't even have to open up the browser. What about this? You still do this faster manually? Anybody think they can do this faster manually? You notice you got multiple pages there, right? So what happens when the thing that you're modifying is the validation algorithm on the 7th page in the 4th section down? How long does it take you to submit that form? It takes forever, right? And now, granted, this is a little bit self-serving of an example. I realize that most of us probably don't have forms like this. At least if you do, I hope that's on a maintenance item somewhere to clean up and make it a little bit simpler for the user. But the reality is that the complexity of our software most often matches this type of situation than the first one, doesn't it? Software can start off simple, but it rarely stays that way. So even if it's not a form like this, you've got another situation that's just as complex and just as difficult to test manually. Who's tried to do manual testing and you need like 17 database records because they're all kind of referentially linked, and you only really need the one at the top, but in order to get a custom one at the top, you gotta make sure the other 17 are there. How big of a pain in the butt is that? In situations like that, what I've mostly seen is that people don't generate their data. They try to kind of import a production database and find a record that works. How much time do you think you spend keeping that data and saying you're looking for records that work, and then, oh, my test broke, and why did it break? Oh, it's because the live data actually got updated. It doesn't match my use case anymore. Seriously, and if I have a form like this, if I have to build a form like this for some reason, I said I could build this form without opening a browser. I can mostly build this form without opening a browser. It's the same thing. I start off with the first field, and I build a dictionary that feeds accurate data, and I just continue to build all the fields on the form, and I eventually start introducing, so I get a dictionary that the form will pass, right? It's valid data, and then I just start on each field, whatever it is that I need to validate, I'll put in bad data, and that's a new test. And if I have 100 fields, I've got at least 100 different tests to validate that changing the input of that field does something. I guess that's not true if it's a text field and there's no validation on it. I think I will test that specifically. I just make sure that the data makes its way through the database. Now, I'm certainly on something like this, I'm certainly going to open in the browser, I'm going to check the CSS. There is things that I'm going to do manually because I can't automate it, but as much as possible, this form is going to get automated. And I'm not even happy with my slides. Okay, so time savings overall. Study this graph for just a second. The yellow line is manual testing, the green line is automated testing, and there's a gap between them. I said that I think automated testing saves time in the short term and in the long term. And I want to focus on manual testing here for a second. We already said that manual testing often doesn't get done, right? So you don't really, most organizations are not going to do a lot of manual testing, like regression testing. They're just not going to do it. And code quality is going to suffer, and that's why most of the software that we use sucks. But I still think there's a really big gap here between the automated testing line and the manual testing line, and here's why. If manual testing is relied upon, the software development process becomes increasingly brittle and error-prone. The developers slow down, and it forces the organization to invest lots of time into manually ensuring that the software is not broken. Where does that show up? How does you actually see this? Long release cycles, months, weeks between being able to release. Where else do you see it?
Spreads back and up, carrying over.
Strings back, yep. There's missing timelines. How about added stress on the developers because there's pressure from the top to produce quality software quickly, but you simply can't do it because the environment is not supporting it. And that weighs on people, right? Well, have you ever been sitting there at the keyboard, you're like, I really need to think about this problem, but you just sense like the manager or customer you just sense them going, man, this needed to be done yesterday. And you need to figure out one way to just get it done quick and move on to the next problem. This affects the developers, the QA staff, management, and customers as releases are delayed and even simple changes take months to get released. On the other hand, you've got the automated testing curve, which it does take longer at the beginning. If you're starting from scratch, going back to the technology fatigue, right? Like, automated testing is another thing I'm gonna learn. How do I test a database? How do I test an API? API's not consistent, right? Okay, so yes, there is a learning curve, but just like everything else that you've done in the software world, at first it seems really hard, and then as you do it more and more, it starts to click. And if it doesn't, if you've been doing software development for like years and it's still not clicking, and you're still frustrated, like seriously consider another job change and hold that against you. Do something that makes you happy. Okay, so over time, automated testing, even though it's going to take more time initially to get that tool base set up, it's going to save time in the long run. Okay, so here's the final plea on testing. Manual testing is not sustainable. Code quality will continually decrease as the complexity of the application increases, and we all know that over time, the complexity of our applications increase. Which means if you're not doing automated tests, the quality of your code base must decrease unless you are expending a significant amount of effort manually verifying that the software continues to function well. You are already testing. Turn those tests into an asset rather than an expense. Use developers for what they're good at, writing code to deal with repetition. Use your QA people for what they are good at. Breaking things, thinking in ways that developers not thinking because they wrote it. UI, UX stuff, things that aesthetics, things that a developer you can't make a computer tell you if that's a good user experience most of the time. And things that are non-repetitive. Use your people for things that they're good at. Use the computer and your developers for things that they're good at. If you're not doing this yet, just get started. Like anything, there's that, oh man, I'm going to have to learn a lot, I'm not going to sure how to do it. Yes, that's true. You will get through it will get easier, and I guarantee you it will pay dividends in the long run. If you really want to get into this stuff and you're at a job that simply refuses and you feel kind of burnt out in software development because of that constant pressure and being in an environment that just does not support building quality software and quick iterations, seriously look for a different job. And I'm dead serious. If you're in leadership, you're like, I don't want to send my developers to a conference where you're going to leave my job, then fix your stuff. Because this stuff, this will kill your developers that do this long term in your QA. That pressure is just awful to deal with. Okay, so we're going to move on to CI. I believe that CI without automated tests is for the most part neutered. If you're thinking I want to build CI but I don't really have an automated test suite, my argument is get your test suite up first. That'll be better ROI for you than starting with CI. The only reason and I wrote this, and then as I was laying in bed, I was thinking, but actually there's an exception to this. If you have a compiled code base, I work in all interpreted languages, but if you have a compiled code base, you actually may get a significant amount of ROI on having a CI system that just builds to make sure that your builds are passing and the compiler's not breaking. So that would be my one exception to this. I do want you to know that I practice what I preach. This isn't bragging. I just want to show you that it is doable. So I've got two projects listed here. One has been going on for 6 years. The other one's been going on for a year and a half. These stats are actually about 6 months old, but they're still relatively useful. In Project A, the 6-year-old project, we have over 8,000 Python tests. We haven't been testing our JavaScript, and really we don't have a whole lot, but we've started doing that. We've got over 300. Our database tables on this project are over 200. We have 145,000 lines of code, and out of that 145,000, 61,000, is testing, is specifically test code. So our code coverage is at 95%. Our test time takes 39 minutes if you're going to run it, if you're going to run them all sequentially. In CI, we've got that broken up into multiple workers so that we run 4 workers, and that makes it about 10 minutes. 10 minutes to do an entire build. We break the tests up in quarters. Looking at the lines of code there for both of them, we've got 42% of in Project A is tests, 42% of our code is tests, and in Project B, we've got 55% of our code, our Python code is tests. Anybody have problems with those line of code percentages? Anybody feel like, man, that just seems like a waste? It's okay if you do, obviously I don't. If you run into people who look into this and would argue all that, you could have spent all that time on building production code, right? Well, ask them this. All the time you've spent testing over the life cycle of your project, what is that? Is that wasted? It is, it's wasted. This is not wasted. This is an asset. Okay, I'm curious, does anybody have a similar project to Project A? It's been going on for 5 to 8 years, roughly the same size, where you're still manually testing? Anybody? Few? How often are you doing releases on those projects? Roughly weekly? When you release, do you have a high level of confidence? No. You should probably ship in bugs? Do you feel like you're probably shipping bugs most of the time? Probably are. Okay, I have another hand. Anybody else? Yeah? Okay, so how fast do you ship? As little as possible. Why? Fear. How many of you develop and release with fear? You know what testing gives you? It gives you confidence. We can release Project A multiple times a day if needed. No problem. And when we ship with a high level of confidence that nothing's broken. Not always true. We still have bugs. This is not perfect. I'm not talking about building perfect applications. What I'm saying is that we have a high level of confidence that when we deliver something to our customer, it's going to work, they're going to be happy with it, and there's not going to be some unexpected problem. There obviously are unexpected problems. We file those as bugs. We write tests to expose the bug, and then we fix it as much as possible. We don't write tests for CSS bugs. I hate those, primarily because I can't automate test those to make sure that they okay. Thinking about CI, here's another assertion. So my first assertion was about testing and the need for automated testing. Without the heavy use of automated processes, especially testing, a truly agile workflow is impossible. Okay, so I'm focusing on automated process. Sorry, I got sidetracked a little bit. So now I'm going to focus on the automated processes part. Yeah, so we're just going to talk about continuous integration. So before we talk about continuous integration, I want to talk about workflow. So this is our workflow in general. This would be true. This is what we have settled on as needing our development workflow to look like, regardless of whether we're using automation or not. We've said that these are the things that need to be done. A, development needs to be on a Git branch, and we prefer smaller branches so that the merges are easier. B, you have to have a PR to get something merged into master. If you commit directly to master on one of my projects, I will take a hammer and I will smash your big toe. It's not allowed. It has to go through PR. I won't really do that. It's unlawful. It's just a better example. Okay, you need to, the code diff has to be reviewed. There has to be somebody else looking at the PR and looking over your code and the other stuff that we're talking about before you merge. The person who is going to merge that pull request, they have to validate that all the tests are passing. There's an assumption that the developer who's done that has already done that themselves. The person reviewing the PR also has to validate that there's no linting errors. They have to validate that code coverage has not decreased unless there is a documented reason why testing something would have been more hassle than it's worth. That has to be in the pull request or commit. And then there also is, we do have some stuff that we push out and we say, hey, there's needs to be a manual QA process, either internally and or by the customer. There's our development workflow. Does this seem pretty reasonable? Does anybody feel like this would not significantly help me reach my goal of sustainably producing software that I've already defined? This Seems like it'd be a good start, huh?
Could I ask a question on the
Sure.
relation to code base?
Yeah, so what he said is, he thinks that, kind of having arbitrary number of code coverage is, how did you say it? Where the he's not sure there's value in that. Yeah, so, what I found is you have to have something to shoot for. You have to have some expectation set. And so minimal for us is 80%. You have to, like, there's no reason, you can, 80-20 rule. Most of the time, getting 80% test coverage is gonna be relatively easy and it's gonna add a lot of value. We actually shoot for 93%. If you're gonna drop through 93, down past 93% on the project, we need to have a discussion about that as a team about why that's necessary. And what that does is, well, yes, it's arbitrary. By setting it there, I feel like I've balanced two things. A, there are gonna be some things that don't have value in testing. They're just not. The things on the periphery of your application, the things that if they break, there's gonna be a relatively small subset of users or people that are gonna be affected. I understand why we might skip that sometimes. We're still trying to provide ROI to the customer, and sometimes I just don't have the time to do it. I actually, in other talks, I talk about, rather than test-driven development, I talk about test-centric development, which means I don't want to be kind of a Nazi about it. I generally want to try for high code coverage, but I also want to balance that with practicality. So I do think having the number helps. It helps set an expectation for what we're shooting for. And in general, I've seen it in us. It doesn't seem to me that we're producing code any slower than the other teams that I'm familiar with. And we're producing code that is regularly above free. I shouldn't say it that way. We are producing code that we can ship with a high level of confidence that there's not going to be a lot of bugs. Okay, so going back to this, how easy is this to do manually? If I'm requiring small code changes, or small PRs as you can manage is reasonable. And for every PR, you've got to do all this stuff. If the reviewing developer has to pull down the branch, manually run tests, manually lint, manually look at a git diff, validate code coverage, both code coverage of the project as a whole, but also the diff of the code coverage to see for the code that changed, is that code covered? How much time is that going to take? At least an hour probably for even a relatively small pull request. So it just takes a lot of time. My argument is, for the average team, if you require all those steps but don't automate it, it's going to eventually not get done. They're just not going to do it. Because it takes too long, there's too much pressure to get stuff done, and I've never met a developer that likes repetitive tasks. They just don't want to do this. And so they're going to find ways to shortcut it, and unless as a manager or leader, you are really kind of holding their feet to the grindstone, like it's not going to happen. If a developer can't find a way to automate something that's repetitive, they're going to usually find a way to stop it. So, going back to my statement, I believe that delivering on my goal requires automated testing and processes. There is no other way. So it's impossible to sustain, I argued earlier it was impossible to sustain this goal without automated testing. I also believe that it's impossible to sustain without automating the development workflow. We already covered that, I'll just speak more since I'm behind a little bit. So this is what it looks like to do this, to have it automated. I've got GitHub, I've got my file changes, I'm assuming you're all familiar with GitHub, right? They can click the file changes, I don't have a screenshot of that. Click file changes, see what actually changed. But then notice some of the other stuff I've got here. I've got current code coverage based on that commit. I've got the total for the entire project, but I can also see that on this diff, the code that changed has 100% code coverage. That's really helpful if you're trying to build incremental, if you're trying to build this into kind of a legacy project, your code coverage might be at 25%. It's really not helpful, right, to know, hey, my code coverage is at 25%. We all know that it's way below. And so, but it can be really helpful to implement the policy where you say, we're not going to accept anything less than 95% code coverage on the diff. So on the lines that have changed. So now what you've done is you've said as a team basically, hey, if we've got a lot of code that's untested, that's fine. We're going to try to build that over time. We're going to build that in. But if you change something, it has to be tested. If you're gonna change a line of code, you have to have a test for that. If it's not there, make sure that you add it as part of your workflow. So I've got code coverage in here. Notice at the bottom that I have my Circle CI is passing. For us, CI is primarily testing. And so by Circle CI passing, I know that the tests have passed. We also have the linter baked into Circle CI so that if the linting fails, it fails the build. So test failure or linting failure fails. That way, the developers know fully what to expect. Linting is not optional. If you fail the build, you can't merge. If this fails, if the builds fail, you cannot merge the PR. You have got to make the builds pass. If you merge code that has failed a test, we're gonna start talking about other things with hammer, right? Like that's awful. It's baked into my culture. You cannot do that. Like seriously, if somebody did that, I would seriously have to sit down with them and say, what gives? Like everybody knows that it's there. At that point, you're basically being rebellious. Like this is the expectation, and it doesn't cost them anything. Most of the time, by the time the reviewer gets to a PR, all this stuff is done. All they have to do is look at it. You know how fast this makes small code change reviews and merging into master? Incredibly fast. Less than 5 minutes for small changes, right? And that makes it really easy to be flexible to respond to small changes, and then it obviously applies to the bigger changes as well. So really, I don't know if you've picked up on this, but what I'm talking about here is more than a process. It's really about a culture. It's about taking these guiding principles that I'm talking about and expecting them of the team. It's also about, as much as possible, enforcing them. So as a leader, it's one thing for me to say, hey, I expect you to do automated tests and I expect you to lint your code. It's another thing for me to say, I've given you the tools to have a build pipeline that's fully automated, that will run that test suite, that will run that linter, and give you relatively frequent feedback. And as a leader, I'm willing to invest in that tooling to make your complying with that requirement as easy as possible. And my developers know if the process gets frustrating, that's something we want to talk about and fix. So I've built a culture that both sets expectations, but recognizes the difficulty of the developers doing it, and then is implementing it as much as possible, tools to make that easy. And all those tools are automated because what the developer wants to do is not have to do it. They want to be able to have a computer do it for them. And that's what I want as a developer. I want the computer to do it for me. I want to do it once, I want to solve the problem once, and then I want the computer to continually help me out. All right, we're going to talk a little bit about just what it's like to set up CI here. I'm going to go through it pretty quickly. The thing to understand about continuous integration, if you don't have it set up, is that it's kind of like eating an elephant. You have to do it slowly, one layer at a time. There's lots of rabbit holes. If you're used to developing on your local machine, you've got everything set up. Now you've got a server that has to build from scratch every time. You've got to make sure all your libraries are there. It's a pain, but it's worth it. It is absolutely worth it. As you do this, focus on constant incremental improvements and build layer by layer. So I program mostly Python, so I'm going to give you an overview quickly of the layers that we deal with in the Python world. Some of these will be translatable, some of them won't. But this is basically going to walk you through how I built up a continuous integration pipeline, and it starts with testing and linting and coverage in a virtual environment on my local machine. So what this means for me in Python is that I need to, on my local machine, be able to run my tests. Right? That's the first thing, because I'm going to run tests in CI, hopefully the same way that I'm running them as a developer. So the first thing I need to do is make sure that I can run the test code. I also want to make sure locally I know how to get code coverage, because getting code coverage locally is almost the exact same way that I'm going to get it on the server, and I need to do that in CI to be able to push that to the code coverage service that we have. Main point here is it has to run locally first. Get it running locally. The second thing is you have to figure out how to manage your dependencies. I'm not going to go into a whole lot of depth in this because managing dependencies are very different. But the heart of the way that we manage our dependencies is that I want all of my dependencies stored with the source code. So in Python, we have wheel files, which are probably kind of the equivalent to like node packages. Like you download them. So what you might find in what's the node build directory? It's node modules, I think. So what you might find in node modules, we kind of package up in a zip file and call it a wheel. In Python, most people will download those wheels on every build. What we've done is we've configured our systems to store those wheels in our system, in our source tree, and then we've set up pip, which is our dependency installer, to read from the source tree rather than the internet. What that does is A, it prevents builds from failing because the internet failed. B, it makes it really, really fast because I'm not hitting the network. It's all installing from disk. And third, and most importantly, at any given time for any given commit, I know the exact dependencies that were there, both library and version number that was used to make those tests pass. I'm gonna skip this because it's really Python specific. Okay, so next, once we kind of have our dependency management figured out, then we've got a test runner. Tox is the de facto Python test runner, and basically what I want to do is I want to use Tox to set up my virtual environments, to install my dependencies from the wheelhouse, run my test with coverage, run the linter, and I want it to fail with a non-zero exit code if any of that stuff fails. Your context is going to be different, but the reason this is important is because any developer can check out any project that we have, and as soon as they're done checking it out, they may have to edit the config file if there's a database to set the database string. But other than that, our process is check out the source code, type Tox, hit enter, and it should run. And if it doesn't, that's a bug, and it needs to go in the GitHub issue tracker, and that is a high priority fix. Every developer should be able to pull the code, hit Tox, and it should run all the tests, so that whenever any developer needs to do something, they know that they're starting from a known good and working condition. I'm gonna see what Tox looks like. Okay, Docker. We added Docker because what we found is that sometimes the developer machine would have libraries, like system libraries, like Ubuntu stuff, live Python, and the CI server would not have it. It was kind of a pain. So what we ended up doing is we just built a Docker container that we knew had everything, and that way, if a developer wanted to test what the CI server was going to test, they could run that same Docker image in the same way. And so what we're doing is we're continually building processes that make what we're running in as a developer is very, very similar as much as possible to what we're running in CI, so that differences are minimized and CI isn't failing when tests are running locally for the developer. This is my Docker run command. It's the heart of the Docker run test script, which is, you'll see later, but basically I'm just feeding it some volume maps there and telling it to run the image. And the Docker flags basically just has some environment variables for the database connection string. Moving on, now that I've got Docker working, I'm going to actually start using Circle CI, which is the CI provider. And this is it. This is my Circle CI coverage or configuration file. Literally, that's all it is. Actually, I take that back. I do some coverage stuff. I'll show you later. Once you do all the work to getting these tests running locally and then add Docker on top of it, running in CI is that simple. You solved all the problems that most people run into when they start trying to do CI by progressing through these layers and solving them locally. Code coverage. So in my test runner, it's one command to tell it to spit out the code coverage data to a XML file, which is a common XML file used to measure code coverage. And you can see it down there. I lied a little bit on the last slide. That very last section is the last part of my circle.yaml file, which is basically running one of CodeCov's scripts to upload all of my code coverage. And I get pretty results in CodeCov, and then we also do some integrations with Slack and GitHub to make sure that when builds fail, we are getting notified very loudly. And what this does is it reinforces that culture. If you break something, you're not going to get penalized for breaking something that's in a PR. What it does mean is that you need to go back right now, or as soon as you're finishing what you've done, go back and get that fixed. It's a high priority. And just putting this stuff in Slack, getting the emails, continually reinforces at a cultural level that automation, continuous integration, this stuff is important. If it's breaking, you need to fix it. And as somebody said earlier that the tests became too hard to maintain, what this means by building this type of pipeline, what this means is that the developers learn ways to make the test easy to maintain, because you have to. You cannot ship code if it's not been tested and CI is not built. That's it. I don't really have time for questions, so I am going to exit, but I will be right out the door if anybody has questions or want to talk about more important